This is a question about joint and conditional probability distributions and their properties. To help you with this question, let's review the definition of a probability distribution function, a joint distribution, and conditional distribution. So in this course, we will use these capital letters to represent random variables. For a discrete random variable, its distribution is described by its probability mass function, p of x, which is equal to the probability that the random variable, again, capital X, is equal to some value, little x. This notation is a little bit confusing because if we had another random variable y, then we will write its probability mass function as p of y. And so the parameter here defines the function that we are referring to. Let's look at the case when x is a continuous random variable. In this case, its distribution is defined by the probability density function, also written p of x, that describes the relative likelihood of the random variable taking on some value. We can integrate over a range of possible values of x's to obtain the probability of x taking on a value within this range. So other important properties include that p of x is always greater than or equal to 0 in both the continuous and discrete case. And if we integrate over all of the possible values of that x can take on in the continuous case, and in the discrete case, if we sum over all the possible values that x could take on, we should get the value 1. A joint distribution describes the likelihood of a pair of variables taking on the value xy. So I could also write this as p of xy is equal to the probability that big X is equal to x and my random variable y is equal to the value little y. Joint distributions are also distributions, so if we integrate over the possible values of x and y, we should get 1. And if my x and y are discrete, then if I sum over the possible values of x and y, we should also get the value 1. Also, if we want to isolate, hey, what is the probability that my x is some value x and y could be anything, then what we do is we integrate over the possible values of y. I'm going to write it this way. That y could take, but x has to take on this value, little x, and we're integrating over the y's. A conditional distribution, like this one, describes the likelihood of y taking on some value condition on the fact that x is taking on this value, little x. So what is the probability, given that I already know that x is this equal to this little x, what is the probability that my random variable y takes on this value? Again, this is a distribution, so we have the property that if we integrate over all of the possible values that y can take, that's going to give us 1. And likewise, if y is a discrete quantity, then this summation over all of the possible values that my y can take is going to give me 1 as well. Conditional probability distribution also has this property called the chain rule, unrelated to the one in calculus that we'll see very soon. This chain rule says that the probability that x is equal to some value and y is equal to some value is, well, we could get it in a few ways. First, we can figure out, all right, what is the probability that x takes on this value x, little x? And given that x has taken on this value little x, what is the probability that y takes on the value little y? And there's a symmetry here, right? So I could also start by asking, hey, what is the probability that y takes on the value little y? And multiply that by what is the probability that x takes on the value little x given that y has taken on the value little y. If we just isolate this last component here, and let me actually isolate this part. So probability that y is equal to x. What is that? Well, I've got the, I'm just going to move this part to the other side. So I've got probability that x is equal to some value given y is equal to some value times the probability that y takes on some value divided by probability of x. So this here is called the Bayes rule, and we are going to see it not until much later, but this is a very important property that we will see later in this course.